All right, guys, check, check. Let's continue on with biological psychology. We're on cognition and language. Cognition and language. So, what cognition means is thought and intelligence and language. So, we don't spend much on cognition, but we do spend a lot of time on language. So, I might break this up in two parts. Human intelligence. It's not about the size of the brain. An elephant or elephants have larger brains than humans. But would you say they're smarter than us? So it's not about the size of the brain. And it's not about the ratio between the brain and the body size. Humans have a 1 to 60 ratio between the size of their brain and the size of their body. Mice have a 1 to 40 ratio. So, yeah. So it's not about the ratio. Our brain compared to our bodies is 1 to 60. A mice, their brain is 1 to 40. And are they smarter than us? So focus is now on the cerebral cortex. If there's more folds in the brain, more sulcuses, more creases in the brain, equals greater surface area. So the way the coming to human intelligence, cognition, think about predicting cause and effect relationships. The way the mind, I asked my professor if it has to do with prudence, or sort of being canny, or being shrewd, being able to see an outcome before something occurs, sort of being able to have reason and being logical and intelligence, right? So predicting cause and effect relationships. So remember, we're focusing on the cerebral cortex. So the right frontal and parietal structures are involved in predicting cause and effect relationships. The right frontal and the parietal structures are involved. And this is shown in fMRIs, functional magnetic resonance imaging, fMRIs. fMRI studies show increased activity in the right frontal and parietal structures, especially in prefrontal areas, visual structures as well, if the cause and effect is observed visually. Okay, so especially in the prefrontal areas, can we predict cause and effect relationships in the right frontal and the parietal structures? There's something called heritability when it comes to intelligence, cognition. Heritability, hereditary. It is clear there is a genetic component to intelligence. Let me do a little side note. There is something called Baldwin's theory. The idea if me, I could learn something so much. It might not have anything to do with this, but there might be a theory that if I decide to learn something so much, I've chosen to learn something, that might embed in my genetics and be passed down to my child, who then is born maybe with the greater acuity to learn that thing. So it is clear, this is heritability. It is clear there is a genetic component to intelligence. It is also clear that genes are not everything, and I agree. Supportive and stimulating environments can improve intelligence scores. Some evidence shows that deprived environments, bad environments, do not reduce intelligence scores much. So these intelligence scores, I think they have to do with common sense, right? Something that they feel, I'm sure they're experts at creating this sort of system and sort of this sort of way to gauge intelligence. Because again, home environment to me, if this person can have all the talent in the world, how many people have talent but have never been given the social psychological necessities involved? Confidence, self-belief, a happy home, being able to express themselves, the space to express themselves, even the awareness that they're good at something, right? They could be suppressed and depressed and sad, and so it is clear that there is a genetic component to intelligence, but it is also clear that genes are not everything. Supportive, stimulating environments can improve intelligence scores. Some evidence that deprived environments do not reduce intelligence scores. Remember, they're not going to tell you this, but it's not being very specific. No, 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 no. It's not being very clear how specific they're being, right? They're not being very, he's not being wordy here. He's creating space. He's figured out a way to, they're not giving so much detail here. It is specific in a way. It's very concise. You got to be aware. There's also something called similarity judgments. Allow for use of prior experience in a new situation. Similarity judgments. Oh, I've seen that before. I know the outcome of that. Oh, wait, I didn't like how that felt last time. Let me not do that. So the similarity judgment is the idea that our intelligence is capable of grasping prior experience in a new situation, which allows us to either use or leave something behind or not do that or do that. Again, prudence and being shrewd and being canny, have the canny ability to navigate properly. And this happens in the prefrontal striatal loop. So, or it says it may be involved. The prefrontal striatal loop may be involved. And this prefrontal striatum. So I guess the striatum is in the prefrontal cortex. So the striatum is part of the basal ganglia. The striatum is very important. The striatum is part of the basal ganglia. Remember, the basal ganglia had to do with like emotions and it was sort of, that might have been the amygdala. I'm wrong. Remember, actually the basal ganglia had to do with sometimes motor functioning. The lesioning of that caused Parkinson's disease. It's procedural tasks. The prefrontal striatal loop may be involved when it comes to allow for use of prior experience in a new situation. Remember, basal ganglia had a lot to do with the procedural memory. The striatum is part of the basal ganglia, and the striatum is the center of executive functioning in the brain. The striatum is the center of executive functioning in the brain. That's what helps us. That's like the thing that says, do it, and your body does it. After all the senses and the neurons went throughout the body, and it's like, all right, the executive functioning in the brain. So that's it. When it comes to intelligence, there's predicting cause and effect relationships. That has to do with the right frontal and parietal structures are involved. fMRI studies show increased activity, especially in the prefrontal areas. Visual structures as well, if the cause and effect have been observed visually. Heritability, the idea that genetics does play a part in intelligence, but genetics is not everything. Supportive and stimulating environments does help with intelligence or intelligence scores, but some evidence also shows that deprived environments does not reduce intelligence that much. What they're saying is if I go pull that motherfucker out of a fucked up situation, maybe show him a little bit, the same as I showed this person, he might be able to grasp it, even though he came from a fucked up environment. That's what I mean by they're not telling you these details, right? You got to be. And then similarity judgments, the idea that you can use prior experience for a new experience, prudence and shrewdness. Now we're going to talk about language. Language. I don't know if I'm going to get that far or all the way. So let's talk about language. What is language? So in the world of science, it's definitional. They have an idea. They don't even have a definition for it. But what I'm saying by it's they have an idea what they consider to be language. It's very specific. It's communication, but with using your lips and sound and how to process it, and knowing how to use language. And you could say you could have two of the same sentence, but you might say one of those words like, why is he doing it? Like, oh, that person has a problem with him doing it. Why is he doing that? Oh, that person has a problem with him doing that, but not because it's him doing it, right? So this is what they mean by language. It's nuanced. So language has a specific order, and order matters. And do animals have language? They do not have language. They might be able to understand our language, and they give an example. There's this gorilla. He knew about 500 words, but it took a long time. They said a baby knows over 1,000 words. This was a grown-up gorilla, and it took a long time to teach him about 500 words. And any baby, new like infant, knows about over 1,000 words. So, do animals know language? Not according to science. So, all right, speaking is complex. It's not just verbal. Speaking is not just verbal, but also producing language. So, speaking is complex. A little quote right here. Why did Ken set the soggy net on top of the deck? So, speaking is complex. First, you have to select words that will express the concept. So you're constantly, remember, a lot of words can mean the same or describe the same sort of thing. Remember, why did Ken set the soggy net on top of the deck? So you have to select the words you want to use that will express the concept. Soggy versus wet, deck versus patio, set versus put. Then you have to arrange them into the appropriate phrases. Arrange them into the appropriate phrases. Set the net on his deck, not set the deck on his net. Remember, so yeah, you have to arrange them into the appropriate phrases. Set the net on the deck, not set the deck on his net. Then you have to look up and arrange their sound structure. Soggy net, not noggy set. So you have to select the words that will express the concept, arrange them into the appropriate phrases. Arrange them into the appropriate phrases. Let me try to list this. So select the words that will express the concept, arrange them into the appropriate phrases, look up and arrange their sound structure. Speaking is complex continued. And then you have to add appropriate prosody, appropriate emphasis. Why did Ken versus why did Ken? Why did Ken? Or why did Ken versus why did Ken? Code the final product into motor commands. So you're thinking about this, and then you have to put it all together, put the words you want to use to express the concept, and then arrange them in the appropriate phrases, and then look up and arrange their sound structure, and then add the appropriate emphasis, and code it all together, codify it into a final product, and then finally comes out your mouth. The motor executive, executing the motor functioning of speaking. All that just to get, why did Ken set the soggy net on top of the deck? So select the words that will express the concept, arrange them into the appropriate phrases, look up and arrange their sound, and have the appropriate prosody, the appropriate emphasis. Put it all together, use your motor command, and get it all out. So comprehension is complex. So speaking is complex, but comprehension is also complex. So word boundaries are not present in wave forms. How do we understand where words begin and end? So our professor showed us this diagram of when someone spoke and they got the person's voice in wave form. So you saw waves of sound. And you saw little gaps, and you would assume that each gap was a new word. But then you heard it and you realize, no. It's sound. So in wave form, you can't see where the phrases are separate. You can't see where the words are bound from one another or separated. A lot of them are intermixed, right? And you get that when people are fluent in a language, a lot of times they don't say things clearly. Like when you hear someone speaking in Spanish, two different, you can tell, oh, I think you don't speak it as someone who came from Mexico. You don't speak it as someone who came from El Salvador, or someone speaks it from Peru. They sound different. They might blend more words together. So when you see language in waveform, and I love it now. Like when I speak in English, I can speak fast, and I can tell that people I speak to that know English, it might take them a little second to understand what I said, but they get it because they've heard these words and they can put it together. But if you saw it in waveform, you would think that the man is reading, that every little break was but no, the man, like, it's blended. So this idea of comprehension is complex. Word boundaries are not present in waveforms. How do we understand where words begin and end? I guess if you're looking at it from a machine. So communication is separate than language. A little side note that I had. Communication is separate than language. Remember, because he asked us, what does language mean? Or Like remember the question was what is language? I thought maybe body language, facial expression. I mean, the fucking thing says body language, right? But in science, when it comes to language and how we first have an input and how we process it and how we conduct the concept of language, put it together, codify it, send it out to the motor command out of the mouth, the output, the motor functioning of language. In science, it's they have their idea, and that idea has to meet their standard, right? So again, continued comprehension is complex. We are unable to take a sound wave and break it into components. We are unable to take a sound wave and break it into its components. Again, comprehension is complex. Continued. Language is ambiguous. Language is ambiguous, meaning it has multiple meanings, both physically and metaphorically. All right, and then you don't really care too much about grammar. What we learn in school, right? What they teach us in school, very formal, very like rules, right? They have rules for this. Don't split infinitives. I don't know what the hell that is. Don't end a sentence in a preposition. Don't know what that is. No double negatives. Don't know what that is. That seems very difficult to even be taught. Wouldn't they teach us that in elementary? That don't even make any sense to me. But what you learn in life, and a funny example he put, when you talk to somebody who, when you, let's say you have a friend that loves computers and you describe him to another friend, you say Fred is a computer lover. You don't say Fred's a computer's lover. Like, what the fuck? His girlfriend's a computer? Fred's a computer's lover. No, you say Fred's a computer lover. So that's something you will learn in life. You never explicitly been told the rule associated with this, but we know what is right and wrong. So you would say, for instance, you would say, man, that's fan-fucking-tastic. You wouldn't say that's fantis-fucking-tick. It wouldn't sound like it made sense, right? Is there a rule for that? You kind of just know that's fan-fucking-tastic. Not, that's fantis-fucking-tick. That's fantis-fucking-tick. Let's said it slow. They'll probably know it was a joke in what you were saying, but the idea that they would take it as a joke, it's sort of silly that he even uses his example. But again, he teaches young people. I guess he try to get their attention. So you insert the word before the first stressed syllable. So I guess there's a rule for that too. So again, let's break it down. Language is complex. Language is ambiguous and difficult to describe. If it is so difficult to understand what language is, how can we even study it? So how to study language, break it down into pieces: production, perception, and grammar. So which two systems in the brain does language use? They use the motor system, which is the prefrontal lobe, and the auditory system, the temporal lobe. There's a little diagram here. Little diagram. I think I'm going to stop it here after this diagram. But we'll be using this diagram a lot. So there's two areas in the brain. One is called the Wernicke area. And it was created by Wernicke and I guess his colleague or some other guy named Leichheim. They have something called a house model. The idea of which two systems does language use? A motor system in the prefrontal lobe. Remember, the motor system, the executive making that decision to speak. And then in the auditory system, the temporal lobe. So the system where it's like Wernicke system, that's sort of going to be the perception area, how you perceive language, how you perceive something and process that concept in your mind, and you respond, right? So the Wernicke's and the Leichheim's house model has to do with perception, the auditory area. So I might end the video after we go over this diagram. So look, obviously you hear something, right? That has to do with Wernicke's area, the auditory sort of system, and the temporal lobe, the Wernicke's area. That has to do with auditory. First you have to hear something, right? hear something, read something. And so that has to do with the ear. Processes all sound, all input, even reading or whatever. So it begins here, right? Up. Begins here, the input. Then you have the concept. Remember, this is sort of theory. You have a concept here, you have to process that concept, and then it goes to the motor function, which has to do with the prefrontal lobe, or the prefrontal lobe, prefrontal lobe, motor. That has to do with production. The production. Movement for language. It's supposed to be lips right here. Movement for language. It's supposed to be lips. So it goes in the ear, process the concept, come out here, and you speak. You respond. You put language into motion. That's the production. That's how you produce. Process, perception. You perceive it. And a healthy mind is going to perceive it, going to perceive that concept, put it together, respond accordingly in a coherent, logical manner. Yeah. If I keep going, now we're going to be talking about sort of aphasias to these areas. The Broca's area. Broca's area is the motor. Has to do Broca's area. We're going to get into it, but we're going to be talking about aphasias. Broca's area has to do with the output. The output. The production problems. How to produce language. The production of language. Oh, there's Angie over there. Yeah, so we'll do another video, guys. Break it down.